What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to have a look at how we can use the area model to visualize expanding. This is going to help us have a kind of a representation of what expanding is and just make sure that we don't miss anything when we're going through quickly in an exam condition. So the basis of this comes from our normal multiplication. For an example, if I have 4 times 12, you might just remember your times table and be like, hey, that's 48. But another way that we could represent this is that 4 is being multiplied by 12, and another way to write that is 10 plus 2. If I throw this into our area model or our rectangles, I've got 4 on one side. 4 is going to be multiplied by the other side. And instead of just writing 12, I can break it down into its tens unit, or 10, and its ones unit, which is 2 for this example. All I now need to do is find the area of these two rectangles. 4 times 10 is equal to 40, and 4 times 2 is equal to 8. So the area of the whole thing is 48, and we're done. This can even be used for harder numbers, right? So if I have 6 times 23, I've got to have 6 on one side of my rectangle, and then I'm breaking the 23 into two components. 20 is the tens, and 3 is the ones. 6 times 20 is equal to 120, and then 6 times 3 is equal to 18. To find the area of the whole thing, I've got 120 plus that 18, so the answer is 138. Breaking these down into the tens and then the ones makes this much easier than just trying to remember your 23 times tables. And it's this fact that we're going to use to help with our expanding. So we're going to use this to answer this question. 4 is multiplied by a plus 5, and we're going to break it down in the exact same way. We're going to imagine that a is our tens unit, and the 5 is still the ones. So I'm going to have 4 on one side of my rectangle, and this time I'm going to have a and 5. Because we don't know what a is, it doesn't actually matter where you break this up on your rectangle. A could be completely over to one side or the other. It doesn't actually matter. I always like to put it kind of in the middle because it just helps me scaffold these questions well. But if I've got 4 multiplied by a, the area of that first rectangle is just 4a. And then I've got to find out the area of the other side of the rectangle. And I've got 4 multiplied by 5, so that section's equal to 20. Now to finish my answer, I just have to write 4a plus 20, and I'm done. So you're actually doing less mathematics because you don't have to actually add these things at the end. You just have to write down what's in each box and plus them together. And this actually works if you've got a variable out the front as well. So for this example, I've got 3a multiplied by a plus 7. All I've got to do is throw these numbers into the position that they would be on my area model. 3a on one side and a plus 7 on the other. All I've got to do now is multiply each together. So this first rectangle becomes 3a squared and the second rectangle becomes 21a. Then my answer is just 3a squared plus 21a, and you're done. We've talked before about how we can do this expanding with arrows, making sure that we multiply both terms by the number out the front. The exact same thing is happening here. I've got my two terms on one side of the rectangle and the number out the front on the other, and I just have to make sure I'm multiplying both things by that number out the front. One of the reasons I find this helpful is you can visualize having two brackets next to each other incredibly easily. For this, I'm going to deal with 5a plus 6 first. I've got 5 on one side of my rectangle and a plus 6 on the other. I'm going to fill those numbers in. 5 multiplied by a is 5a plus 5 times 6, which is equal to 30. From here, I've got to do the other rectangle as well. I've got 2 multiplied by 2a plus 5. 2 goes on one side, 2a and 5 go on the other. To find out the areas of both of these, I just have to do 2 multiplications, 4a plus 10, and that would be my final answer. But now I have to add the rectangles that are the same. Because I've got 5a and 4a, these two a's can be added together using my like terms. So this is equal to 9a, and then I have 30 plus 10, which is equal to 40. So my final answer here is 9a plus 40, and we're done. So this is a little bit easier because you can see the like terms incredibly easily because they're just in a box. And if the same letters are in a box, you just have to add or subtract them as necessary. This also holds up if we've got a negative number. For this one, I'm going to say that one side is equal to 6 and the whole other side is equal to x. I've got 6 and x, but I'm taking away 3 units away from that x. So I'm actually going to use a different color here. I'm going to use red. So I have 6, all that section is x, and I'm then taking away 3 spots from this side. So all I've got to do is work out the area of the 6 and the x, and then take away the area of the 6 and the 3. So this becomes 6x minus 6 times 3, which is equal to 18. So the whole area of that rectangle would be 6x minus the 18 that I've taken away. Using 2 colors here is definitely helpful because it'll just help you see, oh, it has to be negative because I had x the whole way, and then I took away a little bit. Then if we've got a negative number out the front, again, I would highly recommend using 2 different colors. So for this, I've got negative 2 multiplied by 3 minus x. Because I know that negative 2 is going to be red, it's negative, I'm going to put that down there. And then I've got 3 and minus x in that section as well. From here, if it's a red and a blue, it's going to end up with a red number. And if it's a red and a red, it's going to end up with a blue number. So negative 2 multiplied by 3 is equal to negative 6. That's the area of this first rectangle. I know that it's hard to have a negative area, but for this, if you've got it down there, I guarantee you it will make sense. Then I've got negative 2 and negative x. Because these are 2 red numbers, they become a positive. 2 negatives multiplied becomes a positive. So I'm just left with plus 2x. That makes my final answer minus 6 plus 2x, and we're done. Using this scaffold will help you out with those negative multiplications because sometimes it does get a little bit confusing. I would highly recommend using 2 different colors if you've got the time because it will just minimize your chance of making a mistake with these signs. The reason that it's so important is sometimes a negative in the middle of the question can absolutely throw a spanner in the works. But if we're making sure that we've got this area model with our negatives for red and our positives for blue, it'll just help you make less mistakes. So for this one, I've got 2 expansions that I need to do, and I'm going to break them up in half again. I've got 3x plus 2, 3 on one side, x plus 2 on the other. This is just a nice and simple one. 3x is one rectangle, and 6 is the other rectangle. Because these are all blue, I know that they're going to be positive, so the simplified version of that first bracket is 3x plus 6, and we're done. The second one is a little bit harder. We've got negative 4 bracket 6x minus 1. Because I've got negative 4, I'm going to write that at the front of one of my rectangles, making sure that I've got negative 4. Not just 4, I've got negative 4. That negative is going to be taken throughout my expansion, and it's really easy to forget that. So that negative 4 is multiplied by 6x minus 1. To find the area of that first one, I've got negative 4 times by blue 6x. Red and blue means that my answer is going to be negative. So I have minus 24x in that first rectangle. From here, I've got negative 4 multiplied by negative 1. 2 negatives make a positive, so this is plus 4. So what I've got to actually write down is negative 24x plus 4. Now I just have to add or subtract the like terms that I've got. So because I've got 3x and negative 24x, I know that this is going to be negative 21x. The negative number, the 24, is way bigger than the 3, so I know that my final answer here has got to be a negative. So this is just a really good way to make sure that we're not adding 2 negatives together. Hey, I've got a positive 3x minus 24x. That's going to be a very negative number, and for this one, it's negative 21x. Then because I've got 4 and 6 as both positive numbers, I just have to add them together. So I've got negative 21x plus 10, and that's my final answer. So these questions can be a little bit confusing, especially with the signs in the middle. So taking the time to draw out the rectangles if you want, and definitely using a different color when we've got a negative is definitely going to help you out. I would highly recommend using red when a negative pops up, just as a reminder to yourself that, hey, your teacher's probably trying to trick you, and you should slow down just to double check that that negative is going to be there. Thanks so much for watching this lesson, and I'll see you later.